So I'm going to introduce our next speaker. Our next speaker is Mr. Tejinder Singh. So Tejinder Singh currently helms a boutique engineering advisory and consulting service company, which operates in a space that intersects energy efficiency, energy management, and automation. He has more than 25 years of professional experience and has worked in several industries, such as semiconductor industry and electrical consulting. So Tejinder is currently a member of several technical and social organizations, which include the Institute of IEEE, Institute of Engineering and Technology, Computer Society of Malaysia, MYUSGA. He is a registered professional engineer with the Board of Engineers, Malaysia BEM, and a member of the Institution of Engineers Malaysia. He is here to enlighten us about a very interesting topic. It's AI and cybersecurity demystified. So thank you so much for being with us today, Tejinder. I welcome you on behalf of Rocheston and the Reinvent team. Over to you. The stage is all yours. Tejinder, can you hear us?
Yes, I can hear you. I'm setting up my screen.
Okay, great. So over to you.
Thank you. Thank you, Aditya. Thank you to Rocheston Reinvent for inviting me to this inaugural virtual conference. It's an honor. It's a pleasure to be here. And these are tough times. These are trying times. And no matter what's happening around the world, technology moves on, right? And today I'm hoping what you guys can take away is some thoughts that I have on artificial intelligence and how cybersecurity is playing a role in AI and how AI is playing a role in cybersecurity. So this is just a very generic timeline. I will open up with a definition of what AI is, and I'll share a few quotes with some of my favorite practitioners of artificial intelligence, and one of whom I regard as a foremost teachers in the field. I'll share a little bit of trends, a little bit of history, why AI is becoming more and more important, and what are the subsets of AI. I'll demystify some things. I'll scare you with some of the other things, but fear not, right? We are not in that situation yet. There's going to be some little bit of deep dive, so I'll just go a little bit into some definition in an aspect of artificial intelligence, and then I'll tie it up together by saying who and what are playing, what are the major players in the space of cybersecurity and artificial intelligence, and then we'll wrap up after that. So let's start. So what is AI actually? And the definitions by McCarthy, which is considered the father of artificial intelligence, and it quite states that AI, or artificial intelligence, is a science and engineering, right, of making intelligent machines, right, and giving those machines the ability to perform like us, to perform tasks like human beings, right. And when these tasks are actually they include learning from past experience, reasoning, or you discover meaning, or you do some generalization. You and I know, based on that definition, we are very, very far away from that definition. But we are at the beginning. And the other thought leader, I would say, I'm thinking of something else, but I'm a thought leader, is Ray Kurzweil. He is now the director of engineering at Google, and he made this prediction. It states that AI will reach human level of intelligence by 2029, and beyond that, 2045 and above, we will use something known as singularity. And singularity here means machines can actually take over human capabilities. That is his prediction, right? We are still very, very far away from that, and let's see what future brings, right? Why AI is becoming very important? Because as students of computing history, we need to know the fact that the moment way back in 1900s, right, that's when the first analytical engines were built, right? And we have come a long way, where we expect in 2045 those machines are going to surpass us. Why this is happening? Because the pace of change and the rate of change of technology is ever increasing. Moore's law comes to mind, especially when you talk about electronics and chips, right? So this is due to the exploding growth in data, exploding growth in computing power that's accelerating this change. And in the future, we may see a world where machines outsmart us. It's a scary thought, right? Now, Rodney Brooks, he mentions the fact that whatever we are doing in AI today, right, you cannot compare it to Star Trek's warp drive, right? Although that's the target, right? Humanity wants to go to Mars. Humanity is planning to go to the moon, and you can see SpaceX and Elon Musk's plan to go to actually inhabit the colonies on Mars. But that is quite far away, right? We use normal propulsion, but what he's trying to say is wherever AI is today, it is nowhere near warp speeds, which means we are safe for the moment, right? Andrew Ng is a former adjunct professor at Stanford University, and he coined this term that AI is the new electricity. And he said when electricity was invented, it changed entire industries. It revolutionized humankind. It changed industries from healthcare to agriculture. He says now AI is going to do the same. So let's touch a little bit about a brief history of AI, right? And what we hear about AI from the mainstream media is, I'll be back, right? Skynet, we are going to go and we're going to subjugate humanity. And these are all the popular media, the movies have been made, right? And these are very, very bad outcomes for humanity. If you have watched any of these movies, it's not a good idea to be a human in these movies. However, the reality is far from it, right? AI is a tool to help us to do whatever we need to do, and the ability of machines to think like human beings are still very far away. But the commercialization is starting, right? How are we going to end up in 2045? Whether is that the scenario that is portrayed by Hollywood movies? Is that going to be the scenario that we will face? We do not know. However, these discussions we need to start now. The ethics around it, the policies around it, what machines can and should not do, will come into public mainstream discussions. Let's take a look at this graph, right? In 1950, right, a Turing test says that the ability of a machine to mimic human behavior, and that was a very, very first test, right? And shortly after that, at Dartmouth College was the world's first gathering of practitioners, and that's where Professor McCarthy in 1956 launched, coined the term AI, right? And you can see as it goes along, there was a period of uh, depression, I would say, huh? And this is a term you'll be hearing a lot in the economic sense, but there was a depression in technology, and they call it the AI winter, simply because there was a big buzz, there was a hype about AI. AI will solve this, AI will solve that. And those were rudimentary machine learning techniques or computer techniques like expert systems and fuzzy logic and rule-based decision making. And then all of a sudden, the hype died down simply because it did not live up to expectations. So there was actually about 20 to 25-year period when nothing went on. Right? Then, of course, there was an aha moment. A human being beat, sorry, not a human being, a machine called Deep Blue beat the world champion in chess. That's Gary Kasparov, we can say. That happened in 1997. And lately, then soon after that, we have the advent of multiple assistive technologies like Siri, the assistant on the phone. Now we have Google Assistant, and the latest demo of Google Assistant is scary, right? You're talking to a chat, and that chat is actually replicates human responses. I'm sure most of you would have seen that video when it came out last year. We talk about the Watson, which is cognitive computing, and that's when IBM took the project and actually decided to do a lot of stuff with it, cool stuff with it. It's too many things to tell you about here. It beat IBM's AI. Watson beat Jeopardy champions, and if you have seen or played the game Jeopardy, it's a heck of a difficult game to play. Now the end goal here, there's a $5 million X prize, right? And the X prize for AI, which states that if anyone can come, right, and design an AI and they can give a TED talk, you will win $5 million, right? It's supposed to be It's supposed to be awarded sometime this year, but 2020 still has a way to go. So we will see what happens there. Something very, very important happened in 2016, and that's when the whole rush into AI, the rebirth of the AI happened, and that's actually when DeepMind beat world champion uh, in the game of Go. Right, it's an ancient Chinese game. The current world champion was a South Korean called Lee Sedol, and he was beaten by a machine. Right, so that actually shook literally the foundations of the ability, right, the current mindset, right, of what is possible with deep learning. Now, let's go a little bit on the underlying concept, right, of AI dimensions and applications. So you and I would have heard many, many terms, right? We would have heard the mainstream media would like to say is AI. Every software is AI enabled, right? Autonomous driving is AI enabled. Your cell phones AI enabled. Your smart TVs AI enabled. But what does it really mean, right? AI is just a very broad topic. We need to talk about expert systems, right? We need to talk about recognition services, machine learning, and that is something that is very prevalent. It's becoming more and more. I won't say more and more popular, but these are the subsets of artificial intelligence. And of course, we talk about natural language processing, and that's where you have speech to text and text to speech conversion, and that is becoming quite exciting field to be in. Now, aside from that, this is the historical perspective. From an economic perspective, right? It's going to be a boom. It's going to contribute about $16 trillion to the global economy by 2030, right? And you can see from the slide that lots of investments are being made all across the world. China is doing a lot of investments. North America is also doing a lot of investments, making a lot of investments. Europe, Africa, Asia, we are way back in terms of investments in AI. And I'm actually reading a book by Kai-Fu Lee, right? So in that book, he talks about this field is going to be dominated by two entities, China and the United States, until and unless something incredible happens. Policy changes, more and more people take up AI. Things are going to be status quo, and you can find these two nations fighting it over to be the major player in artificial intelligence, right? And I'll qualify the term artificial intelligence in later slides. Another perspective, right? A subset of artificial intelligence is called machine learning, right? And they are now machine learning startups, machine learning companies, solutions are now target of a humongous amount of funds and estimates. This is March 2019 dollars, right? It's machine learning applications are now attracting up to 28.5 billion, which is still not a lot compared to the $13 trillion that we expect this entire economy to encompass. Now, I'm going to throw you another term, right? And the term is called deep learning. So now don't get confused. AI, ML, deep learning. I'll show you exactly how it all fits. But look at the screen. Look at the ecosystem now. There's a lot of startups using deep learning. And why I use deep learning? Because deep learning is a artificial intelligence or AI technique that was used by Google's DeepMind, produce a software called AlphaGo to beat the Go champion, right? And they used deep learning to actually defeat the human player, right? And you can see almost every aspect of human life is touched or is being touched or will be touched by deep learning, by machine learning, or by artificial intelligence. And you look at the bottom of the screen called security. So we have signal sense, deep instinct, and jumbo CV. I'll talk a little bit of this eventually. Now, what about the hype, right? And this is actually an old slide, July 2017, but the hype wave is almost the same as today. And you look at the top of the curve, right? You can see there is connected home, deep learning, machine learning, and of course, you talk about autonomous vehicles. It's currently 2 to 5 years. So 2 to 5 years from 2017 is right about now, isn't it? And it is actually the peak of inflated expectations. Yes, now we expect AI and machine learning and deep learning to do virtually everything for us. where does that leave us, right? We're not going to be lazy bums, right? We're not going to sit on our butts and drink coffee and watch TV all day long, right? We still have to design the systems, and we still have to maintain the systems. So the hype is there, but we need to be cognizant of the fact that it could be eventually the wave could move to the right, or wave could move to the left, right? Now, this is actually the hype cycle, and you can see it's been going on. And this is actually a slide from Deutsche Telekom. They are also a very, very big player in aggregating solutions for that. Right now, right, at the point, there's a lot of work being done, a lot of applications out there. Primarily, they are still in proof of concept and still in R&D, right? So now remember the hype cycle, right? The Yeah, I'll skip to that. Now, a little bit about deep learning, right? And why this is a topic that's close to my heart. Simply because to me as an engineer, right, and to me as a practitioner, I like to look for solutions to problems that we as human beings face, right? Be it in energy, in water, in food, and healthcare. These are all solvable problems by using appropriate technologies. So deep learning, I believe that's my take. It could be a solution to one of those problems. Now, allow me to just uh, go down a little bit in them, right? And this is a very nice slide, or this is a very nice portrayal of where machine learning and deep learning fits within the umbrella of artificial intelligence, right? So artificial intelligence, because they have no better term to use it, they cannot use fuzzy networks or rules or expert-based systems. They all coined it, lumped it together into this bucket called artificial intelligence. But as we went along, machines, we decided when our computational technology and our knowledge increased way back in 80s, and that's when the not nuclear winter, AI winter happened. We tend to put all these new techniques into this bucket called machine learning, which is fine, even till today is still applicable. But the another field that just recently opened up, and in the slide you can see from 2010s, I would say early 2011. But when it really took off, is in 2016, when Google's AlphaGo software beat the human player in the game of Go. Some AI or deep learning in the news, you probably would have seen this. We are expected to see a self-driving car in 2020. However, I think Tesla is going to beat NVIDIA. NVIDIA is also producing its own car. Google's Waymo, I think, is down by the wayside. And a major player currently, there's also some Chinese competitors. And this term, autonomous driving, self-driving, you will see, or you are, and you have been seeing in the mainstream media, and it's happening, guys, right? And this is some images from there. You probably would known that Google's AI, and this is very scary, right? The applications of AI actually in these aspects, you can actually lip read, right? Software can actually lip read us. And can this be used for good, or can this be used for bad? I have no idea. The technology is there, and using this, the term deep fakes and deep videos come into mind, right? And that's all possible because of artificial intelligence, deep learning, and machine learning. There are a few more slides. I'm just going to run through it. But I need to actually share this with you, right? Despite of all the hype that you would have seen in the mainstream media, all the hype and saying that yes, deep learning and machine learning and AI is going to solve all of humanity's problem. Let me show you what it takes to build a very simple system. I won't go in that, but just at a superficial level, on an abstract level, I'll just show you exactly what is required, right? So in deep learning, I would categorize them in 3 areas. There could be 4 or 5 areas, and this field is evolving rapidly on a day-to-day basis. So we talk about supervised learning, we have unsupervised learning, and we have reinforced learning, right? And in each of these areas of deep learning, right, we have uh, neural networks, we have autoencoders, and we have deep reinforcement learning here. So just let me go through very basic on high level what it is all about, right? An artificial neural network is based on a human mind, right? And when you have a neuron, you have many inputs and you have an output, right? And then you have the screen on the right. a mathematical set of equations, right? So let the mathematicians, let the researchers figure out exactly how this perceptron works. But me as an engineer, we like to take the output of this research and actually build a real life application that helps us all. So what is an artificial neural network, right? It mimics our brain simply, right? And you've heard the term art imitates life. Here maybe life imitates art. Which is which? You figure it out, right? So the dendrites and the neurons and the axons, these are all this what makes our brains up, not mind but brain. If you look at the right, and I apologize for the graphics, I think the line types are not thick enough. You can see the red row of inputs. The middle are the hidden layers and the right are the outputs. So that's how an artificial neural network works, right? Or the basic building block. And you can stack these layers up and it becomes a convoluted neural network eventually. But let's talk about this reason. Why is it hot now? Why wasn't it hot in 2010? Why wasn't it hot in 1990s? Why 2016 onwards it became so popular? Very simple. Our computing power has increased. We have lots of data available. We have GPU acceleration. We have these video cards, right? And we have new techniques available. Now, two schools of thought in GPU acceleration. Some of you might be thinking, aha, let's do cryptocurrency mining. Let's do Bitcoin. That's the idea or the image that comes to mind when you talk about GPU acceleration. However, there's another flip side to the coin, right? GPUs can be used to train your learning models, your machine learning models, and they have a use for that. Now it's clearly there's a battle between AMD and NVIDIA. AMD has gone to serve the crypto mining industry, and NVIDIA has decided to throw his turban or throw a hat into the deep learning community. Right now, some basics. I'm just going to just explain very superficially the basics of deep learning. So we talk about pattern recognition, and one of the very simplest application of deep learning is facial recognition or image recognition. And this is something known as a classifier, simple classifier. Cat or no cat, dog or no dog, human or no human, right? So basic classifier, so it's binary, one or two. And you can see it's quite tedious because you have to label your data properly, right? If you have unlabeled, unstructured data, classification is going to be a pain and you need to put in a lot of effort. So it says that, I extract the features, I then train a simple classifier and then have an output. So you can build this up relatively simple. So if I want to say, for example, apply it in agriculture, plant or non-plant, right? Or weed or non-weed. And it can work up to a certain level, but then you want to see how yields are, how temperature affects the soil conditions, how are the soil conditions, how weather patterns, then a simple classifier cannot work, right? If you go a bit more deeper, deep learning, right? Not a simple classifier example, but a deep learning example where you use neural networks. That's when you start to extract the features, right? And this is slightly bit more accurate, but takes a lot of computational effort to do that. And these are the hierarchical representations, right? You have low-level features, high-level features, extremely high-level features, and then you transfer this value. So, and you classify them, and you get an output. So, the more layers you have, the more abstract it gets. Then you can assign some certain weights, right? This is all quite technical in a sense. But it's how deep learning works, right? And when you talk about image recognition, it'll then look at the pixel, look at the edges, find the motifs, is it dark or is it light, and then gets trained on that, and then you have an output that you desire from text character recognition, and this can be used for number plate recognition, right? If you have a vehicle number AYZ XYZ 1234, you can actually then train to actually detect certain license plates or registration plates and provide access or do not provide access to it. So yeah, it can be trained. A convolutional neural network is an extension of neural networks or an extension of ANNs, right? And this is where you how should I say, for want a better word, it's you only connect the hidden layers if you need it. So, and there's a process to drop these layers if it's not really relevant to the output. So once again, we require data. We require lots of data. And in today's time and age, day and age and time, right? We have literally petabytes of information on the internet. Google has tons of information about you, Facebook, Twitter, Instagram. These are all sources, and that's public. What about that's not public, right? So you can imagine, right? The size goes big, and there's a lot of data out there, and machine learning and deep learning can actually make sense of it if there's a problem to be solved. A little bit on supervised, unsupervised learning. So there's a difference between supervised and unsupervised learning. Supervised means I tell you exactly what to look for. So CAT or non-CAT, right? But that takes a lot of effort, isn't it? So that's a technique called autoencoders, where you train it once and the machine learns on its own, right? And you have the hidden layer. You have many hidden layers. So you have output, and you train as says I want this, I want to recognize a cat, right? But then when I put a dog or a plant, it is able to say yes, it is a dog, or it's a plant, or it is a human being, right? So all depends on what you put in, and then you get what you want. Garbage in, garbage out, remember that axiom. So we need to know. Now there is a difference between reinforcement learning and deep reinforcement learning. I will just skip through this. Deep reinforcement learning, this technique, right, is actually mimics how a human being learns, right? And you can actually train a machine to do that. And this is a technique that Google's DeepMind used to develop AlphaGo that defeated the human Go champion. Subsequently they had a couple of matches since, and AlphaGo has beaten. The other very good deep learning and reinforcement learning example is Dota 2. I don't know who of you, anyone in this audience plays Dota 2, but OpenAI's software, right, trained on deep reinforcement learning, defeated Dota 2 champions, right? And I've tried playing Dota 2. I've given up because it's quite a intensive, and the gameplay is huge, right? And I just literally was overwhelmed when I tried it. So a machine now can beat human players. Now we come to the pertinent question, right? How is all this relevant for cybersecurity, right? Why is AI important in cybersecurity, or is it important in cybersecurity? If it is, what machine learning algorithms can be used? What deep learning can deep reinforcement learning be used in cybersecurity, right? We'll get to that. Before that, let's examine some trends, right? Now, there are many cybersecurity trends to watch out for: 2018, 2019, 2020, right? One is from Forbes, and one is from a website which is simplylearn.com. The trends in cybersecurity is there is a potential for artificial intelligence, right, to play a role in the defense of our networks, in the defense of our systems. Now, I want to clarify here. Media likes to use the term artificial intelligence. I like to go in depth and find out what sort of artificial intelligence is this media talking about. So could it be a machine learning algorithm, or could it be deep learning? So this is something we need to discern, and we need to be quite we need to actually critique this news that comes to us, and be able to digest is what's being said. Forbes has said that AI is going to be ever present in cybersecurity. Once again, we need to ask Forbes exactly what it means. But later on in the same article, it mentions machine learning and deep learning algorithms, and there are many out there, right? And allow me now to actually put up a list of companies, cybersecurity companies that have used or are using machine learning. I would say most of them are using deep learning techniques, right, in their product offerings. And one of my all-time favorites, I have 2 or 3 all-time favorites on this list, but this is my all-time favorite, right? Darktrace. It's called self-learning cyber AI. It's a digital immune system for your networks. And it's come to my attention that a lot of organizations around the world have started to use this. And I believe a lot of universities are also starting to use this, right? Because they want to know exactly what's happening in their networks, and if these networks can defend the networks from a malicious attack autonomously, right? Just like disease, right? I get a flu, I get a fever, and I get cured, right? The fever is a response of my immune response. It's my body's response, an immunological response to the flu that I contracted, to a disease that I contracted, and my immune system takes care of it, right? So Darktrace is actually in the business of providing an enterprise immune system, right? Check it out. And this is one of the leading players using deep learning, right, in the offerings, and of course deep instinct, right? We're talking about zero time prevention here, and using predictive analytics, and this deep instinct also uses deep learning. What algorithm they're using, I do not know, because it's proprietary information. So if any of you knows what sort of algorithms they use, do let me know. But this is a very good and up and coming firm, and they have secured millions of dollars of funding a couple of years back, right? And these guys are products that are really available out there utilizing artificial intelligence, right? So whenever you hear the term artificial intelligence, you can maybe switch, say, is it machine learning or is it deep learning, right? Or others that's not here yet. CrowdStrike, right? They have what do you call, um, an AI platform to provide visibility and to provide protection. So what kind of protection and visibility CrowdStrike has got is this AI platform to actually detect way before it happens. Once again, uses predictability, right? This is a new company, right? Cyber AI that you can trust. It's actually network detection and network response. So you notice here that the current market is actually more on network protection and device protection, and from a cloud basis or from off-prem or on-prem. Right? No rules, no signatures, no sandboxes. That's what Blue Hexagon is selling us. This is another new startup, which is something very new. And there's a new trend called zero trust network model that a lot of organizations are actually looking at. That means I don't trust anyone. And they have a product offering, zero trust networks, and they actually sell, or they are in the business of actually providing such models here. Now, what is the next step? If you look at this slide from CBI Insights, most of the companies I mentioned in previous slides are already on this slide, right? We're talking about Silence, right? Silence, Deep Instinct, Idani, Darktrace, Avata, CyberX protects industrial networks, Clarity protects industrial networks, and all of these use anomaly detection. That one I know for a fact, and that's about the only thing they can do in industrial networks, right? We cannot do active scan. We have to only do passive scan. So anomaly detection is one way of actually doing. And how you do that, you need to have enough data to do predictive analytics to say, hey, this is anomalous behavior, and we're going to stop whatever it's doing. Where else, or how AI is going to be used or is being used? You have seen examples of it. In moving on, because moving on from now on, they will use cybersecurity professionals, right? Are going to use this to provide protection on endpoints, right? They can use this to provide mobile data protection, right? And because with the increasing use of BYOD policies, bring your own device policies in corporate organizations, we need to have a handle of what's going on in our networks, and we just cannot rely on human beings monitoring the screen to alert the security team on intrusions or attacks. So we got to rely on automation, right? Now we will use this analytics to actually detect any anomalies, right, in patterns, in traffic, and of course in any user activities. One of this is active research is being conducted. No company has produced, but this is something that I would like to see, is that you are able to predict a patch before an exploit happens. How's that, right? That is that's something some organizations are working on. There's a couple of research groups that are actually actively utilizing machine learning algorithms to actually ensure that before you get exploited, you already have a patch for that, right? And once again, the more data we have, the more prediction we're able to do, the more granular data that we get, we are able to be as accurate as possible in detecting stuff. Some of the supervised learning algorithms, which is part of deep learning, is support vector machines, Bayesian networks, and so on and so forth. Where else are we going to use AI in cybersecurity, right? Network intrusion detection, right? Using artificial neural networks. We saw network threats, right? So it's something very similar, but intrusion detection is quite specific tooling that we have, and that AI can actually support that. So all the major players who are offering NIPS, NIDS solutions are actually now looking into machine learning and deep learning to enhance their offerings. I mentioned anomaly detection using predictive analytics. This is very, very useful in environments where you cannot do an active scan. Otherwise, you don't want entire process of production to crash. And of course, the next wave is actually detecting malware, or preventing ransomware. So once again, AI, machine learning, and deep learning, they are very good at making predictions, right? And this is something that we need to continue working on. And I'm excited about this field because it's still greenfield. There's not many players in, and the startups and the companies I mentioned earlier just the tip of an iceberg, right? Um, Top 5 use cases currently, what I found, where AI is being used. You've seen some of these companies, detection of malicious activities, right? And where they actually stop the attacks, and detection of those is dark trace. You've seen that. Zimperium, which is a mobile security provider, is actually has a product to actually analyze the mobile endpoints, right? And there's a startup called Pattern X. It actually does human analysis, or enhances human analysis of the predictive data. That means AI or deep learning will give you a result human being needs to analyze, right, before take it to another step. And Pattern X is the one that helps the human being to make a decision. And of course, the benefit of AI, the use cases, this is not completely done yet, is actually to to automate repetitive security tasks, and of course, zero-day vulnerabilities, right? And currently, um, according to IBM, right, this is what they mention as top 10 trends in cybersecurity. It's actually responding to ransomware, detecting other threats besides malware, right? Have adaptive tokens, or adaptive honeypots or honey tokens. You know what honeypots do, and you know honey tokens, right? So we want to make sure that they adapt so that the attackers continue getting lulled into the fact that yeah, we have found a good target, but that's not the case. There's also a move towards combining application development and cybersecurity. DevOps could be the answer, right? Where you have these two trends coming together, using deep learning to do generative algorithm generated domains. So that means the machine learning will actually generate domains for you from DNS point of view. And the next trend is we still do not understand how neural networks work properly, right? Still called black box. So that's raising flags in the mindsets of certain CISOs that hey, I do not know what's going on in black box. Do I need this in my environment? So those are some of the points, right? Protecting the IoT, and of course predicting the future. So those are the top trends of AI in cybersecurity. My thoughts, and I'm going to wrap up very soon, is AI. And when I say AI, I hope you know that AI means machine learning also, and also deep learning, right? And all the algorithms you can find, all the machine learning algorithms, all computational algorithms, right? And there are many schools of thought whether there's a clear line between this is an AI algorithm or this is not an AI algorithm. Let the researchers figure it out. I want to use this information to build applications. Um, Artificial intelligence or deep learning are very good at solving specific problems, but they are not good at solving general problems. That is the domain of AGI, artificial generative intelligence, which Ray Kurzweil says is many, many years down in the future. When you talk about lots of data available, and we need high quality data labeling to make sure that our algorithms work right. AI is going to be a very great tool to have in our toolkit. Right? We have many toolkits at our disposal, but this is going to be a very, very good, very, very useful toolkit, addition to the toolkit. All right. We are quite far in the end goal. Our end goal is let the machines do everything for us, right? But we are very far away from that. We cannot design a robot that will take over the world at this point, but we have designed a robot that we can tell people to social distance themselves, right? The robot from Boston Dynamics is a case to point. Right? So that's still far away from world dominating or robots that's going to kill a human being, right? My time is up, and I think yeah, I
Yeah.
leave the
Hi,
floor to
Tejinder.
you. Thank you.
Thank you, Tejinder, for that very, I would say, as simple explanation that you could give for such a complicated topic. Now, we do have a couple of questions from viewers. First one is, what is the application of real-time computer vision-based automation for enterprises?
What is application of real-time computer vision for enterprises?
Computer vision-based automation for enterprises.
Okay, a very good automation example is your access, right? And right now, access to organizations are card control or biometric, or even a security guard at the main entrance. But if you have facial recognition that is already predefined to allow X number of people or only authorized people to enter the building or the facility, and all you need to do is just show up at the corridor or show up in the hallway, and you're granted access. And obviously, proper security principles needs to be put in place, like man traps, vestibules, and so on and so forth, and cameras. That is to actually cover the physical security aspect. So, off the top of my head, yeah, facial recognition or automated computer vision application in real life is access.
Okay, thank you. I think we have one question that's been repeated twice by two different people. So what are your thoughts about graph core?
Graph code has, I've not dabbled so much in graph code, but it has promises. I've not really seen a real life application. I've not seen any companies offering solutions with graph codes, but that is something definitely to look at. So, I have no opinion on graph codes at this point in time.
Okay, so one last question I'm going to take. What are your thoughts on Elon Musk's Neuralink and brain chips, and will its implementation have any health issues?
Okay, from a technology point of view, I'm a technocrat, I'm an engineer, so I love all these new technologies, right? But having said that, Elon Musk has got his own views on AI, and he feels that there needs to be ethics in AI, and then he has pulled funding from the OpenAI Foundation. What he's doing, I think it's something that is necessary, but we do need to put proper safeguards. So Neuralink is Neuralink, right, Aditya?
Yes, Neuralink.
Yeah,
Neuralink.
it's augmentation, right? It's augmentation of the human being, and it's going to be a matter of ethics and moral, and whether is it really required or not. So it's just an open-ended question. We are heading towards that, and I think humanity needs to be given a choice, and it should not be shoved down our throats. Right? We should be given a choice. I've known of a professor who has implemented an RFID into his arm. So whenever he goes, he just sticks his arm and the door's open for him, right? So that's an example. Is that a cyborg? I have no idea. That the question is still open.
Okay. Thank you so much, Tejinder, for that very insightful session.
Thank
you so much.
Thank you for having me here. Take care. Have a good day. Bye.
Bye.